For years, APIs were the glue that held software together. You define an endpoint, you send a request, you get a response. Clean, predictable, perfect. But the moment large language models entered the picture, that model started to crack, and a new standard is rising fast: the Model Context Protocol, or MCP. Some are calling it the biggest shift since APIs themselves. So what is MCP? How is it different from an API? And why is it reshaping how we build AI agents? Let's break it down. First, a quick refresher. For decades, an API has been the universal handshake between systems. One program exposes an endpoint. Another sends a structured request, usually JSON, and gets a predictable response back. Developers document it, secure it, version it. It works beautifully because both sides know exactly what to expect. But a language model doesn't work like a normal program. It might not call one endpoint. It might call 10, chain them together, interpret messy data, and ask follow-up questions. It doesn't just need access to a tool. It needs to understand the tool. And that's the catch. APIs were built for programs talking to programs, not for models reasoning about the real world. To a model, an API is like a locked cabinet. It has to know exactly which drawer to open and the precise shape of the key. It can't see what's inside, which function to call, which parameters to pass, until you tell it. So you hardcode it, and you explain it over and over in longer and longer prompts. That's the problem MCP was built to solve. Instead of you teaching the model about every endpoint, MCP gives the model a standardized way to discover what a tool can do on its own. What inputs it expects, what outputs it returns, all through context. Think of it as handing the model a live, machine-readable map of your tools, instead of a static instruction manual. Let's make that concrete. Say you're building an agent that manages support tickets with access to Gmail, Notion, and Jira. The API way. You write custom code for each one. You handle auth tokens, pagination, rate limits, error cases, and you teach the model in long prompts. To create a Jira ticket, call this endpoint with these fields. To reply to an email, send Gmail this payload. The MCP way. Each service exposes an MCP-compatible interface. The model discovers those tools automatically and understands what they do as part of its environment. You don't tell it how. You give it context, and it figures out which tool to use and when. That's the core difference. An API is a code-level contract between two applications. MCP is a semantic protocol between a model and its environment. You're no longer teaching the model which endpoint to hit. You're giving it a toolbox and letting it reason about which tool fits. And that shift is bigger than it sounds. With APIs, the logic of what to call and when lived in your app code. With MCP, that logic moves into the model's reasoning itself. You can build one general-purpose agent that plugs into any tool that speaks the protocol. No rewriting code for each integration. Take PaperOffice. Its AI-OCR and document processing already exist as an API. Your code calls them, pulls out the fields, and you build the integration. Expose those same tools over MCP, and the client changes. Now you just ask Claude, what do we still owe Acme Supplies? And it searches your invoices, checks the payments, and matches the delivery notes. Then answers grounded in your own documents, without ever having direct access to them. Same tools. Your code reaches them through the API. A model reasons over them through MCP. So what's actually happening under the hood? An MCP server is a lightweight process that sits next to your service or data. It describes what it can do and which functions it exposes using JSON schemas. The model connects over a standard interface, HTTP or WebSocket, and receives that metadata. From there, it calls functions directly, not by guessing, but by reading the schema. It knows the required inputs, what each field means, and the shape of the output. Everything is self-describing, so instead of building 100 bespoke integrations, you build one MCP interface, and every compatible model can use it instantly. That's why people call MCP the plug-and-play layer for AI. Now, an important clarification. This does not kill the API. APIs are still the foundation. They're how your systems actually work. MCP doesn't replace your backend. It replaces the middleware between the model and the API. The MCP server acts as a translator, turning your existing APIs into something a model can understand on its own. So it's not really MCP versus API, it's MCP on top of APIs. What changes is who the client is. With an API, the client is another program. With MCP, the client is the model itself, and that one change rewrites how we design integrations. It's the same story as HTTP. Before the web standardized on HTTP, every service spoke its own protocol: FTP, Gopher, Telnet. Once HTTP unified them, everything became interoperable. MCP is trying to do that for AI agents. Build your connector once, and any compliant model, Claude, Gemini, GPT, can use it. The future of AI tools looks less like custom integrations and more like a shared ecosystem where models, not just humans, are first-class users of software. It's not all magic yet. MCP is new, and adoption is the biggest hurdle. Servers, clients, and tools all have to agree on the standard. Security matters too. When a model can call tools directly, you need clear permission layers so it can't accidentally send an email or delete a file it shouldn't. The spec is adding scopes and authentication, but it's early, and there's a mindset shift. Most of us think in endpoints and routes. MCP asks us to think in capabilities and context. So, to sum up, APIs aren't dead, they're evolving. APIs were made for deterministic systems, one program asking another for data. MCP is made for probabilistic ones, a model reasoning about what it can do. It's not a head-to-head comparison, it's a foundation being rebuilt. MCP, sitting one layer above your APIs, turning static routes into living interfaces a model can actually reason about. Here's what that looks like in the real world. PaperOffice reads a document live, every field on the page, in any layout. Vendor, invoice number, amount, due date, all extracted and verified automatically. And it's the very same skill an AI agent can call on its own over MCP. And this is already real. PaperOffice AI exposes its document tools, AI-OCR, intelligent document processing, and three-way matching through both an API and an MCP server. So your own code can call them the classic way, and any AI agent that speaks MCP can discover and use them on its own. The same tools, ready for humans and models alike. See it at paperoffice.ai.